Okay, so system design practice time. So in this video, we are going to cover a very popular question called Design Yelp system, or it is about designing point of interest. So let's start with this question. So let's say the question is something like, let's design a system to find the nearby restaurants. So this is a rather broad and obscure question. So the first step is always try to scope it to define the feature requests and goals and non-goals to further look at what are the specific features we are trying to design. So first of all, we need to ask some questions to clarify the feature requests we are going to have. So let's say for this one, what are we trying to care about? Go. So I assume we are not going to cover the UI UX design, and we are not going to cover the mobile app design, but we are mostly covering the backend service part. And to turn this broad business requirement into some more fine grade or more specific words, let's say we are designing a backend service to try to find top 100 restaurants based on the user's location, and the return result is sorted by sorted by distance between the user location and the restaurant location. We don't care about, for example, ratings and the category of the restaurant the user is interested in. And also, suppose we are in a very suburb area, there's not too many restaurants. We are not going to search beyond the radius of 100 miles. So we are only going to search within the 100 miles radius. So now we have some better wording about the feature request. So we are covering the backend service. We are only trying to search the top 100 restaurants within the 100 miles radius. And also the next thing I want to cover is whether this app is for US users, or it is like a worldwide app. So let's say we are going to firstly focus on the US customers. So for this, it would make things a lot easier. We don't need to care about too much about like time zone, like internationalization, etc. So like here, UI UX front end design, mobile design, it is not going to cover. Let's say there are some other features which are very common, like for example the comments, like restaurant owners can also upload pictures, like editing the restaurant information. So for those features, those are not covered. So we are only going to cover the backend service design to find the top 100 restaurants within 100 miles radius for US customers. Okay, so after we scope this problem, we need to do some constraint analysis. So this is about to help us understand what kind of system, what is the scale of the system we are trying to design. So let's say we are targeting the 100 million daily active users. Let's say mostly the user base is among, let's say, 500 users, but only 100 million daily active users. Let's say users. So let's say each daily active user is going to give us one queries per day, per day. And due to the nature of the business, because it's about searching the restaurant, so I would expect the traffic to be very spiky. So for example, during the lunch and dinner time, that's when the most of the traffic happens. So for the 100 million daily active users, it is distributed into different time zones. So let's make some fair assumption. Let's say we have 30 million uh, 30 million of the queries happening within like 1 hour. So 30 million within 1 hour. So this one we will have like 8,000 queries per second, like 8K QPS for the peak time. And also we have the restaurants. Let's say how many number of the restaurants are there. So let's say we have like 10 million restaurants in total. So that's a fair assumption about the numbers. Let's say we have this we need this system, this backend service, to be highly available. Let's say we have the availability to be 99.99 availability, and also the latency, let's say 90% of the queries have less than 200 milliseconds. So let's see, we are targeting about 500 million users. So within the database, let's say each user, so mostly it's about like the name, like the ID, like the name, etc. So those schemas, let's say we have 1K per user. So 1K per user, it is going to bring us for 500 GB about the storage. And let's say for the restaurants, let's say we have 10K for the schema because there is a restaurant description. So let's say for this one, we are having about 100 GB regarding the total storage. So I think so for storage is not that big, and the traffic is fairly, it is pretty fair there. So now we have some very good numbers about what kind of system we are trying to define, and based on the number, we can also have fair resource management to coordinate the servers, and also we can choose which kind of data storage we are going to use in the next step. So after we do the constraint analysis, it's time for us to do some design overview. So for the design overview, it is more about the architecture level, about the service, and also we understand the general data flow among different components and the dependency of the different components. So usually for the backend service, we could have multiple of the service which depend on each other, and their data flow between each of them. But we need to illustrate about this when in the overview part. So let's say the user, first of all, it is going to send some HTTP request where the network, first of all, is going to hit our load balancer, and it is the load balancer is send the traffic to a app server, and then the app server is going to send some RPC request to our backend server. And the backend server is going to query our database, but before the database, usually there is a cache layer to cache some results. Yeah, so that's pretty much about the general stuff we are going to have, but we still need to think about what are the services live in the backend server and the DB, for example. So let's say for DB, usually we need to consider the replication part. We are going to have several different slaves to make sure we have redundancy about the data, and also to try to avoid single point of failure. So we have the load balancer. We can have two load balancers listen to each other. When one goes down, then the other goes live, becomes a master. And for the backend server, app server, it's going to be groups of the servers. So along the path, we try to avoid any single point of failure in design, and now I think we should be in good shape. So what are the backend servers we are going to define? So the first thing I can think about is based on the user location, which is, so essentially it is a user lat long. We need to return a list of the restaurant IDs, and we need to return a list of the restaurant IDs. So let's say we have so I'm thinking whether we should return a list of the restaurant IDs along with the lat long of the restaurant. I think returning the ID plus lat long might make sense, but if we don't have the lat long of the restaurant, we can further get that by querying the restaurant database. So let's say we have, the first one is to search restaurants. So the request is a proto buffer containing the user's essentially it is just a user lat long, and the response is a repeated field including the restaurant ID. Let's say if we return with lat long, is it really useful here? I think it should be okay. So let's say the RID and the lat and the long, etc. So this is about search restaurant service. It is going to, based on the user location, return the restaurant ID and the lat long, etc. And let's say we have another thing called a restaurant info service. This one, we are going to have the request send as a list of the restaurant IDs, and the return response will contain the restaurant infos. So essentially it is also a repeated field, and each is going to be the restaurant ID, like the lat long and the name, etc. It is all about the restaurant info we are going to return as response to the app server, to the front-end server. So the general overflow, the general data flow is like the user send a request to load balancer then redirect the request to the app server, then app server send RPC request to the backend server. So within the backend server, based on the lat long in the request, we are going to get the list of the restaurant ID and the corresponding lat long. And then we can, based on the user lat long and the restaurant lat long, we can do a computation about the distance and then further sort it into a list. And then we query the restaurant info service to get the corresponding info for each of the restaurant to be returned to the app server. And of course the restaurant info is from DB via cache, etc. So I think restaurant info service, there isn't too much room to talk about that because there really isn't too much room to talk about that. And for search restaurant service, I think we need to touch the geo-indexing strategy about that, which I think is the most important part, and it is a bottleneck for this service. Oops. What did I do? Okay, so here. So the next one is about detailed design. So in this part, it really depends on the interviewer's interest, which way he wants to direct you to. He will ask you some questions about different components, to ask the detailed design among different components, but it really depends on which branch he wants to go. For example, like the DB design, the backend service design. But I would say the bottleneck part is the search restaurant service based on the lifelong to return the list of the restaurant IDs. But let's start with the DB part. So for the DB, we have the restaurants table, the user table, and of course we have the geo-indexing stuff. So for DB, for the user and the restaurant, it doesn't make too much of the difference to use SQL or NoSQL, whatever. So let's say we are using SQL to store users and the restaurants. So let's say we use SQL for this. Well, I think SQL is a little bit hard to extend, because if you need to add a new column, you need to change the schema essentially. And also when the data volume becomes too large, so for example, let's say we have 10 billion, not 10 billion, so like what billion users, let's say 5 billion users. So then I think then we need to like have different replicas, maybe add more replicas to make sure that we have more latency, and also we need to care about the data sharding, etc. So I think it's okay to use SQL, but maybe use non-SQL is a better choice when we have large volume of the data. But in this story, it doesn't really matter much whether you use SQL or non-SQL for the restaurant and user, and for the restaurant and user. So let's say for the user, we have the ID, the name, like a description, etc. And for the restaurant part, we have like the ID, the name, and category, rating, etc. So after that, we also need to define the storage for the geo-indexing part. So for geo-indexing, there are several ways to do it, and I believe there are some geo related data storage for that. But I'll just talk about the ways to do geo-indexing. So there are different ways to do it. So for example, we could use geo-hashing, I think. Geo-hashing. I think it's geo-hashing, right? Geo-hashing. Yeah, it's the geo-hashing stuff. And also we have the quad tree, and we have the R tree. So I think R tree is pretty commonly used in the all the ways are pretty commonly used though, but R tree is also, I would say R tree is a very good way to do it. So let's say what that is. So essentially most of them, all of them, all look very similar. So let's consider the whole Earth as a surface. So we are going to divide the whole Earth into different grids or different rectangles. But in our case, for some different areas, let's say for the suburb area, we have way less of the restaurants than like the downtown New York City. Like in downtown New York City, we have a lot of the restaurants. So in that case, we don't really need to have all the grid to be of the equal size. So for the suburb area, we could have larger rectangle, but for the area like downtown New York City, we have smaller rectangle. So we just want to make sure that each rectangle is filled with a with a certain percentage of the restaurants. Let's say each rectangle is going to each rectangle contains 10 restaurants. Yeah, so let's say if I use some way to do it, maybe use this one. Okay, so this might be okay. Let me yeah, so essentially this is about geohashing. Sorry, about the geoindexing. So let's say we merge the cells. Let's say sorry, just dry throat. So let's say this large rectangle represents the suburb area, which contains way less of the restaurants, and those more dense, smaller rectangles represent some metropolitan, some downtown area. But essentially, you want to fill the different rectangles with without too many of the restaurants. So when it comes, we need to store. So of course we need to store this kind of data structure in the database to have permanent data storage, and we have essentially data replication on top of it. But we also need to have this kind of data structure to live in memory for fast serving. So for example, let's say the geo, let's say Earth area. So the whole Earth is like 196, 196 million miles square. Okay, how to say that? Square feet, square mile. Okay, square mile. Okay, so let's say each grid in average is 1 mile by 1 mile. So then we are only going to have 196 million, which is like 196 megabytes in total. So it's not very big. So considering it is a tree like, it is still within like gigabytes. So it is easily memory fitting. So first of all, we need to have this kind of data structure to have permanent storage. Let's say we use a database to store the tree like data structure, and also for fast serving purpose, we need to store this structure in memory in our search restaurant server service. The search server that is serving the search restaurant service. So let's say we have the lat long, and we use the geoindexing. Let's say we have the R tree data structure to find the grade, and based on the tree structure, we can easily find its nearby cells, and then within each cell we have the corresponding restaurant ID and the lat long of the restaurants. So, and now we should be easily have a list of the nearby restaurant IDs we are going to return there. And also, I think maybe another thing that is worth mentioning is how are we going to do the search within the R tree. So it is a tree like thing. So for searching the nearest neighbors, we usually use some queue like search. So it's like, the tree, like the top layer we have larger grades. It is going to to cover a lot of the grades, and then for the children it's going to cover a subset of the grades, something like that. So first of all, we are going to so we will have this is a larger cell pushed into the queue, and then we have the smaller cell pushed into the queue, and then smaller and smaller cell pushed into the queue. So the reason we do this is because smaller cell. So the reason we do this is because suppose in the smaller cell it doesn't have enough restaurants we are going to return, then we are going to add more stuff from the top layer of the things, topper layer within the queue. Let's say smaller cell doesn't have enough restaurants to return, then we are going to return the restaurants from the smaller cells. Okay, so that's essentially about the search. And also it is worth to mention that at the very beginning it says we are only going to search within the 100 miles radius. So at that point we are actually limiting the range of the tree we are searching for. So that's a very good thing. So for the now we have I think we have a general idea about how to implement our search restaurant service. So it's essentially based on the user lat long. We know which cell, we know the corresponding grade of this lat long, and within the grade and the neighbor grades. So actually for this grade, we are also going to have some neighbor grades. So within the current grade and the neighbor grade, we are going to have a list of the candidate restaurants that are nearest to the current lat long. And then we have the grade ID, and each grade we are going to get okay, so based on the grade we have the list of grade ID, and within each grade we have the restaurant ID, we have a list of restaurant ID plus the lat long, and we will further compute the lat long with the user lat long to compute the distance, and then we are going to return the top 100, let's say the top 100 restaurant IDs, top 100 restaurant IDs. So that's essentially how we build the search restaurant service. And also I think it's so also for some, I think there's also some well-known stuff. For example, some well-known issues. So for example, it's something called like for example, hotspot or celebrity problem, whatever. So essentially it's like this. For some hot areas like in New York City, around the Times Square, there are a lot of people there, and they're trying to essentially within the same grade trying to send queries from the same grade, and this can cause us to go over and over again to the same grade and return the list of the return and do pretty much very similar queries for that. So for that case, what we could do usually to solve this kind of problem, we could build some cache layer. So for the search restaurant service, there are two ways. Search restaurant service. So for the search restaurant service, first of all, it is going to of course it's going to based on the lat long we are going to get the grade, and we are going to see if the grade already exists in the cache layer. So if yes, we don't need to query the in-memory data structure for the neighbor grades and then get the list of the restaurant IDs. So instead, in the cache layer, we are going to store the grade and the let's see which one we should store. So should we store the grade to the neighbor? Should we store the neighbor grades, or should we store the list of the restaurants? So I think we could store, actually, because we are just storing the restaurant IDs, which is definitely not big. What we could do is, based on the grade, we store all the restaurants from the neighbor grades. So in this way, when the same query from the same grade is then sent over, then we can actually just return the result from the cache for that. And other than the cache layer, it is in-memory geo-indexing. So now we talked about how we do the search, how we build the search restaurant service. So let's see what is left there. Yeah, so I think we covered the hotspot issue. I think there isn't too much here that we should cover. Yeah, I think there isn't too much we should cover. And I think it is worth to mention that for the cache layer, we are going to use some distributed cache instead of the local cache to build the service. So other than that, let me see what other things that is worth to mention. Okay, so maybe it is worth to mention that if you have time, maybe some questions about restaurant info service. For restaurant info service, it's fairly simple. So essentially, you also have the cache layer. If the restaurant ID falls within that, you just get it from the cache. Other than that, you query the DB. But due to the size of the restaurant, so it is very easy to fit in RAM. So we don't need to worry too much about cache miss, whatever. Okay, so I think there really is something worth to mention. So for example, the geo-index update. So for example, let's say suppose a restaurant owner upload so there are some new restaurant owners and they upload their restaurant information. Is it going to be, are we going to update the geo-indexing like immediately, or are we just going to do some batch update? For example, let's say waiting for half an hour, or just for waiting for 1 hour to collect enough restaurants, and then do an update, and then update our permanent data storage about geo-indexing. So I would say like some fair latency. So for example, let's say 1 hour latency, it's okay. So for it depends on the aim of the system, but I think for many of the systems in the prod, it's okay to for the restaurant owner to wait for like maybe 1 hour for the system to update to include their restaurant information. So other than that, I think we should have covered mostly about we have covered most about this question about this Design Yelp or POI system. Yeah, so that's it for this system design question. So if there are any follow-up questions, it really depends on the interviewer. So if you have any question about like the solution or about whatever of the system design interview question, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.